Welcome back to Math 109, Plane Trigonometry. In this video, we're going to take a look at the quotient theorems, allowing us to divide complex numbers using trigonometric form. So like with the product theorem, we're going to start out by taking two generic numbers in trigonometric form. Okay, so now that we've done that, we're going to make the key step here, multiplying the denominator by the conjugate of just the cosine theta 2 plus I sine theta 2. So that would be cosine theta 2 minus I sine theta 2. So now we can go ahead, we're going to use FOIL on top. So I get R1 cosine theta 1 cosine theta 2 minus I sine theta 2 cosine theta 1 plus I sine theta 1 cosine theta 2 minus I squared sine theta 1 sine theta 2. We'll divide all of that by R2, and then I'm going to use the rule for difference, or the multiplying by the conjugate, which is real part squared plus imaginary part squared. So now, again, we're going to play the identity game that we played on the last one. We're going to go ahead and factor out the R1 and R2. I'm also going to make the key move here that we know cosine squared theta 2 plus sine squared theta 2 is equal to 1. So I only at this point need to worry about the numerator. Also going to take note that I squared is equal to negative 1. Then we have minus and negative 1, so that's plus a positive. So the numbers without i's in them give me cosine theta 1 cosine theta 2 plus sine theta 1 sine theta 2 and then for the imaginary part I will add I times sine theta 1 cosine theta 2 minus cosine theta 1 sine theta 2. The real part is simply still have the R1 over R2 out front. Real part of that is simply the cosine of the difference. let me draw that, or write that a little bit better. So it's cosine theta 1 minus theta 2. And the imaginary part is simply going to be the sine of the difference of those angles. So plus I. I do not need that extra parenthesis there. I sine theta 1 minus theta 2. So now writing this in the more compact form, we have R1 CIS theta 1 over R2 CIS theta 2 is equal to R1 over R2 CIS of theta 1 minus theta 2. So that'll do it for section 6.3, or 8.3 of our textbook. In section 8.4, we're going to talk about powers and roots of complex numbers with a theorem known as de Moivre's theorem.